All right, hey guys. I hope you're happy to hear my lovely voice on this beautiful day. This is your first thing for e-learning, so we're not gonna do too much because I'm sure you have other things to do, and as we're in advanced format, like it's not super stressful. So I'm just gonna keep introducing new sequences. There's one thing I kind of want to do today, and that's a general term. So we talked about that last week. Here, I told you like the general term is the thing that ends up here in your curly brackets. So in this case here, you would have an equals to n. And then after that, what you would want to do is just name the first four terms. So you would substitute, you would start at n equals to 1 and then go forever. In this case, we're just going to stop at 4. So your first four terms would be 1, 2, 3, and 4. And then for this one, the second one, an was equal to 1 over n, meaning that your sequence is going to be 1, 1/2, 1/3, and 1/4. 1/4. We did this one as well from what I recall. So 3n plus 1. So your sequence was always one more than every factor of 3. So we're going to start by 4, and then 7, and then 10, and 13. Now this one here was the one that we stopped at, and that's one of the interesting ones. It's called an alternating sequence, alternating, and I'm going to use that language quite a bit. So if you go here and plug in for n equals to 1, then this is going to be a negative, so you're going to have minus. And then n plus 1 is going to give you 2. So you're going to start at minus 2. And then after that, if you plug in n equals to 2, this is going to become a positive 1. So it's going to be positive 1 times 3, so just plus 3. And then after that, minus 4 and 5. So it's called alternating because every second term is positive and every second term is negative. So it's switching signs. Now the next one, also pretty simple, the square root of n minus 3. So we're going to start at 3. So your first term is going to be 0. So here, notice that I specified it start at 3 because otherwise we're going to get numbers that are not real. We don't want to deal with that. So we're going to get after that 1 because square root of 1, then square root of 2, then square root of 3, and so on. I think I'll skip the cosine. We can deal with these things a little bit later. Let me see. I don't know if I can scroll down from here. There we go. Okay, the interesting part is when we flip this question. So for instance, here, I'm going to give you a sequence and I want you to figure out what the general term is. So just by looking at this here, we have even numbers. So typically even numbers will be given by something like 2n. So does that work? So 2 times 1, 2 times 2, 2 times 3, 2 times 4. Yeah, that seems like it works, but it has to be a fraction. So 1 over 2n would be your answer. Now this one, first thing I noticed is the fact that we have the alternating sign. So to create the alternation, we're gonna need a minus 1 to the power of n or n plus 1. So if it's just n, then you're gonna get minus 1 to the power of 1 for your first term, which is gonna be negative. And this is supposed to be positive. So to switch things around, we're gonna say this is n plus 1. So now if I have n equals to 1, this is going to be minus 1 to the power of 2 for your first term, which is a positive number. So that works out. So that is going to create your alternating sign. Now, if we look at the numerator, 3, 4, 5, 6, 7, they're increasing by 1, but they start at 3. So I think what we need to have is n plus 2. Because then when n equals to 1, you get 3. When n equals to 2, 4, and so on. Now the bottoms a little bit is pretty interesting too. 5, 25, 125, 6, 25. So be careful not to be like, oh, this is times 5, this is times 5. This is not helpful. You need to figure out what is the link between n and the number that you see here. So if you have 5, this is 5 to the power of 1, this is 5 to the power of 2, this is 5 to the power of 3, this is 5 to the power of 4. So as you can see, it has to do with the power. So this is going to be 5 to the power of n, and that's going to be our general term for this one. 2 more. So this one here, again, it's alternating. So minus 1 to the power of n should work. And after that, it just increases by 1 every time. So it's going to be multiplied by n. Now the bottom, 4, 9, 16, 25, these are all squares. So it's going to be something squared. It's not n squared because if it were, the first term would be 1, but it's 4, 1 over 4. So it would be 2 squared, 3 squared, 4 squared. So we're shifted by 1, which is why I have my n plus 1 squared. Let's do the last one just to be sure that you get it. But if you want to pause and try it beforehand, please be my guest. It's a good idea to do that. Okay, 2, 7, 12, 17. So what do we have? We increase by 5. So if we increase by 5, but we start by 2, maybe that's not a good idea. Let's think.